Hello everyone. My name is Siran, and this is my demo video for workshop 10. And first of all, I'm gonna start with task 1 and show my code and try to run my code to see the output. The task 1 is about the matrix multiplication. So we have 2000 times 2000 matrix, two of them, and multiply by each other. And we're gonna use multi-threading techniques to solve the problem. So first of all, we're looking at the multiply matrix class. This class is the test class. We have several constants to be defined. We set rows to 2000. We set columns 2000. And we assume we have 5 threads to perform the multi-threading. Also, we have a matrix A, B, C. A, B is for calculation. B is for the results. Or also we have an init matrix function here. So this function gonna using random value to populate random value to matrix A and B. Also we have another function called display matrix. So this one is try to display the matrix, the result or the value of the matrix into the console, and give you an overview about the matrix value, but it's only displayed the first 5 and the last 5 columns, so it's quite big, so it cannot display everything. And after that, we have two approaches: parallel multiply and sequential multiply. Parallel multiply is going to use multi-threading to do the calculation. Sequential is using like a normal way, single thread. Uh, After that, we create another class called multiplication task. This is a runnable class, so it can run as a thread. And the idea of this task is very straightforward. It will divide. It can divide the matrix A into like a small portion with starting row and end row, and multiply matrix A by matrix B and return the result to matrix C. So that's how this task works. So when we back to the multiply matrix class, if we check out the parallel multiplication here, you can see we have a thread array here. We have 5 threads here, and also we divide the columns for matrix A into small part here. Each part here in this case is 400 rows, and we increment by 400 every time in the for loop, and create a thread with this particular task with start and end row. So this is very straightforward, and once we start every thread, we wait everybody to finish calculation and return the results. For sequential multiply, this is much easier because we don't need multi-threading, so we just create a single task with starting from the beginning to the end, from 0 to the end. We call the run function, and because the run function is not we're gonna perform as a thread. It's gonna be a normal function and return the results. And then in the main function here, it's just we're gonna test the sequential first, and then the parallel, and we're gonna calculate the time for each calculation. So now we're gonna have to run the test here. Run this one, yeah. So as you can see, first of all, we're gonna generate some random value for matrix A and the matrix B. Not all of them, but not all of them are displayed. So we're gonna display only the first 5 columns and rows, and we're gonna test the sequential matrix, sequential multiply matrix. It take a little bit while because normally if you times 2 matrix, 2000 times 2000 size matrix, it's gonna be a 4 million calculation here. So it's a little bit slow here. So we just keep waiting. Keep waiting. Yeah, you can see now it's complete. It take me like 44 seconds to finish the execution, and there's the results. Also, we're gonna have next one. We're gonna have a parallel matrix here. Totally threads 5. It only took me like 10 seconds to finish that, and it returns the result. And you can see the result is exactly the same. Yeah, exactly the same. So this task shows that if I using multi-threading to perform the same calculation, you're gonna save lots of time for that. So this is task 1. Yeah. Uh, okay, let's move to task 2. So task 2 uh, is about deadlock, and we have draw a little picture to show the logic for this one. Okay, as we can see, we have 5 people here try to eat, and with 5 chopsticks, and each person represent a thread, and it try to execute one task, which is eating, and each one of the chopsticks represent a resources, and we try, and if each person try to holding one chopsticks at the same time try to grab another one, they're gonna wait forever because there are only 5 chopsticks in this case, so there will be no more chopsticks available, and so that's why we're gonna make this resource synchronized. And also very important things is we have to make people put down their chopsticks every time they're waiting for another one, so they cannot waiting for one chopsticks with other on their hand, so to avoid deadlock. So there's 2 approach to solve the problem. The first one is using a waiter. The second one is setting rules for each thread to let thread communicate and to avoid that problem. So we're gonna use the second approach to solve the problem. So here we're gonna first of all gonna create a simple class called chopsticks. It has a boolean property called in use, and the setter function we create, we make it synchronized to avoid a conflict. And also we have a table class. This is a tester class. We have 5 chopsticks, and we have 5 threads to execute it. This is very straightforward, so I'm not gonna go through that. So the key point is the person. So for each person implements runnable, so each person can run their task as a thread. So according to the second approach, the first one we're gonna do is to find their chopsticks for each person. So find the location or for the position for their chopsticks. So we're gonna find their left one and the right one. We're gonna know the index for the left and the right. After that, we're gonna into a while loop. So the reason why we're gonna use a while loop because this action cannot be performed only by one time. So it's gonna keep trying, keep waiting for their available chopsticks. So it's gonna be a while loop for everybody to waiting for their chopsticks to be available. So when we're into the loop, we try to pick up the left chopsticks first. If the left one is not available, you just simply wait for another second, wait for the next round. If the left one is available, pick up the left, wait for 1 second, try to pick up the right. And the important thing is if the right one is not available, so we just put on the left and wait for the next round. So we cannot wait holding the left and keep waiting right. So this is not gonna work. So if both left and the right are available, and in my hand we check actually locked both resources here, and eating for 2 seconds, and unlock the resources, unlock the chopsticks, and exit the while loop. So this is how we run this method. So right now we're gonna have a test on that. So we're gonna say table. Yeah, you can see I've had 5 philosophers. So you can see that each one of them trying to pick up, put down, pick up until they have a valuable chance to do that, and all philosophers finish this meal. We can try that multiple times. The result might be different, but they all uh, they can avoid deadlock using this approach, and everybody can have its meal. Yeah, all philosophers. So once all the threads are complete executing, there will be tell us all philosophers finish its meal. Uh, Also, we already provide. I also provide another approach or other way to solve the problem. If you can see that, we try to use another class called reentrant lock. This is provided by Java. So if we're using reentrant lock, we don't need to create chopsticks class. This class can represent the resource object, and if we can see this one, we have 5 reentrant locked here, right, to represent chopsticks. And similarly, using the same logic here, we in the run function, we first of still we find the position for the lock, left and the right. Also run into a while loop, and the reentrant lock has a method called try lock. It's gonna return a boolean value to show if the resource is locked or not, or try to acquire the lock for the resource and return the results immediately. So similarly, it will try to lock the left. If not, gonna wait for next round. And if the left is locked, wait for 1 second. Try to lock the right. If right is not available, similarly unlock the left and wait for the next round. Only if the both left and the right are locked at the same time, we start eating for 2 seconds. After that, unlock both left and the right, and finish eating. Exit the loop, and we can run that here. It will have the very similar logic here to avoid deadlock. So both approach are acceptable here. And actually the reentrant lock is much powerful because it can have much more different method to avoid conflict or to avoid deadlock, and we don't have to create our own classes like chopsticks, and we're just using the reentrant lock. That will be much more easier and much more efficient to do that. So every time we run this program, the result might be different. The time might be different. Sometimes it takes a little bit while. Sometimes it's very fast. But eventually, everybody gonna have its meal. Everybody gonna finish eating. So this is how we use this both approach to avoid deadlock in multi-threading, and that's pretty much for the task 2. And thank you for listening, and I will upload my code to the Blackboard, and thank you for listening. Bye bye.